Yes, students, can you see the PPT?
Yes, ma'am.
Yes, students, today we are starting a new module. I'm going to start a new module, that is last module, that is fifth module, fault-based testing, planning and monitoring the process, documenting, analysis and test. This is the fifth module. In this module, what we are going to learn is the assumption in the fault based testing, mutation analysis, fault based accuracy criteria, validation, variations, the test cases, all these things we are going to learn in this module. So the name of this module is, students, that is fault based testing, planning and monitoring the process, documenting, analysis and test. And the prescribed book for this is software testing and analysis, process principles and techniques. So this is the prescribed book for this fifth module. This is a prescribed book for this fifth module. Yes, students, in last module, what we have learned is system testing and integration testing. In integration testing, what we do, we combine the small subunits, and after combining, we test the model. So that is nothing but a integration testing. Whereas in the next, we learned the system testing. In system testing, I told our intention is not to find the fault in the system, just to check whether everything is correct, to check everything is correct, because once I start working, I should not face any difficulty in between. So that's why before I gave a simple examples also, other than the technical, the other non-technical examples also I gave. When you travel to some other place, to your native or to your friend's place, when you start traveling, before we travel, what we do, we check the condition of the vehicle. We check the condition of that vehicle is nothing but a system, no? That vehicle is nothing but a system. So we are checking the system whether it is correct, whether it is working properly. Here there the intention is not to find out the fault in the vehicle, just to make sure everything is smooth, everything is fine. Next, we have here in this module, we have in the name itself, it is they are telling that fault based testing. Here we are mainly focusing on the fault. Any fault is there, any problem is there. Why? See, if suppose if I have a software testing lab, so what according to lab set, if assume that I have 10 set of programs, so 1 to 10 program, assume first time if I'm handling the software testing lab, what I do is from first to 10 program, one by one program I'll execute. So I'll in the third program I face some difficulty. In the third program I face some difficulty, or in the third program, the topics what we are learning in the third program, those topics come at the end. Maybe the topics are coming in the fifth module. I'm handling the subject first time. Maybe first time I may not having the grip on that subject, I may not having the complete knowledge about the subject, so I will execute in the sequential order. When I take the same subject second time, when I handle the same subject second time, beginning only I'll be knowing, yes, third program, whatever the theory part is there or whatever the concept is there in the third program, that comes in the last module. So I execute the third program at the end. I execute a third program at the end. See, first, when I do a first time, I'll come to know the fault. I'll come to know, so yes, this in the third program, it is not matching the syllabus, the topics are, or the theory concept is there in the last module. The first time I have handled the first time, so I was not able to identify this fault. So that's why when I handle the subject second time, what I do is, already I face that difficulty when I handled first time. So now what I don't want to repeat that mistake again. I don't want to repeat that mistake again. So what I do, first I'll exclude 1 to 10 program, excluding third program. Excluding third program. The third program I'll execute in the at the end. Why? Because to just to match with the theory concept. Just to match with the theory concept. Yes, these are all the small changes we do when we come to know what is the fault. Correct, no? Correct, no, students? So here, when you run a program also, if your program has any error, then we'll come to know what is the fault. Without compiling your program, can you find out what is the fault in your program? No. So for that, first we need to compile the program, so that we'll come to know the what is the fault in my program. So I'll try to debug. And try to debug the error or the fault in the program. And once I get a success, once I get no error, then I proceed to the next program. So here in this module, we are focusing on the fault-based testing, planning and monitoring of the process. So what process we are following to identify the fault, to identify the error. So what process we are following, and how we are planning, and how to monitor, and based on that the documentation, analysis and testing we are going to learn in this module. So this is the prescribed book. This is a prescribed book for this fifth module, that is software testing and analysis principles, process principles and techniques. Introduction. So the model of potential program fault is available source of information for faulting and designing the test suite. So once I come to know the faults in the program, it will be helpful for us to design the test suites. Test suites is nothing but the test cases. So the potential program faults is valuable source. See, the faults is yes, students, what is fault? Fault is nothing but the mistakes or error in the program. These errors are potential. These program errors are potential for us to develop a test cases. These errors or these faults are potential information for us to evaluate and design the test cases. The fault-based testing uses a fault model directly to hypothesize the potential fault in a program under test, as well as to create or evaluate test suites based on its efficiency in detecting those hypothetical faults. First, here we'll understand what is hypothesis. Anybody? Anybody know what is hypothesis? The hypothesis is nothing but our assumptions. Hypothesis is nothing but our assumptions. So once I develop a small program or a larger project, so my assumptions will be there. Yes, students, without assumption, can you develop any program? So before I start developing a project, my one assumption will be that the user interface will be like this. The functionalities, these are all the functionality I am going to include in that project. And once the functionality coding, everything is ready, what are the test cases I want to do, I want to implement. Yes, or these are the assumptions. These are all the assumptions we do when we start developing any project. Martivalva? Yes. So before we develop a project, we do some assumptions. We do some assumptions. So fault-based testing uses a fault model directly to to hypothesize the potential faults. So once I develop a project in the fault based testing is we are the aim of this fault based testing is to check what are the faults I have made in the program or I have made in the project. Made in the project, so that to evaluate and detect the fault, to detect the fault, to resolve the fault, to if I have done any fault, or if fault is nothing but error. If I have done any error, so I should try to debug the errors. I should try to debug the errors and detect where I have done the error. Once I detect the error, once I find out where I have done the error, once it is completely resolved, then I'll be able to reach my hypothesis. Correct, no students? If my program is not having any faults, then I can be reached my hypothesis. I can reach my hypothesis. Hypothesis is nothing but my assumption. Hypothesis is nothing but the assumption or the supposed output or the supposed output or the expected output. If my program has any faults, then will I be able to reach my hypothesis, students? No, I cannot be. It is not easy. It is not possible to reach my hypothesis. So that I have to evaluate. I have to evaluate the test cases. I have to evaluate the test cases and try to debug all the faults in the program. Try to debug all the faults in the program. So now we have the overview of this fault detection. Overview of the fault detection. Engineers study failure to understand how to prevent the similar failure in the program. So engineers are nothing but it may be a developer or the test engineer. Here we are not segregated, we are not specifying a particular engineers, whether he is a test engineer or a developer. Generally the whoever is going to develop a project, they are going to study the failure. They'll study the failure. Why they study the failures? So that to understand next time they don't want to repeat the same failures in the future. Assume that I have a company, I have a mechanical company. In my company I'm manufacturing a car. I'm manufacturing a car. I have included some of the functionalities for airbag. I have included some of the functionalities for airbag. So when to on the airbag. Some yeah, students, if we don't wear seat belt, then the airbag will not open. Correct, no? Am I right? Correct. Yes, my students are there or not? Idira,
Yes, ma'am.
36 to 35 students are there. So out of 35, not even single student is responding. Yes, yes. Am I right? If I don't, yes, students, am I right? If I don't wear a seat belt, the airbag will not open. Is it right? Correct? Whatever I have assumed, is it right?
Yes, ma'am.
Hmm?
No, ma'am.
No, no. I don't know exactly. Just I'm assuming.
Ma'am, if you didn't wear seat belt, like this one won't like open.
Yes.
Airbag won't open, ma'am.
Correct, no? My
Yes,
assumption is
ma'am.
right. Students are there. Okay. So I have developed a company. I have developed one car. So front. Every time I have to change this. So I have developed a big car. So front, 2 seats, back, 3 seats. So now this is my first car. I have developed a airbag only for these 2 seats, first these 2 front seats, and the condition is if they wear a seat belt, only then the airbag will open. So now after after once I launch my car, so many people are going to buy my car. So I'll come to know that some one of my company car met with an accident, and because of those people who are not wearing seat, the people who are those who are sitting at the back seat, they don't have. I have not provided an airbag for these back seat people, so they got severe injury. So because of that airbag, so these people have airbag, so they have not so minor injury happened. So these three people, those people who are sitting at the back, so they got a major injury. So what I do, so this is a failure, correct? No, I have not included an airbag for the backseat people. So this is the failure in my product. So next, when I launch a new car, so I try to include airbag for the back seats also. I whether you I think you people also know that for some cars, only for the driver seat the airbag will be there, correct? No, am I right? For some cars, for both the front seats they'll give a airbags, correct? Am I right, students? Yes or no?
Yes, ma'am.
Okay. So for some car, if for some cars only for the driver seat they provide a airbag. For some cars, the top high end cars. So both for front seats, both front seats they give a airbags. And now I came to know that because of not having a airbag in the back seats, they met with an accident and seriously they got injured. So now I want to improve my product. I want to improve my product in the future. So what I do, I try to include airbags for the back seat also. Yes, students. So like this, so the engineers will study the failure to understand how to prevent the similar failure in the future. Here they have given one example. The other example I have the one, I have taken a different example here. The car example I have taken here. They have taken a different example. For example, the failure of the Tacoma Narrows Bridge in 1940 lead to new understanding of oscillation in high wind and the introduction of analysis to predict and prevent such destructive oscillation in the subsequent bridge design. So here they have taken a bridge design. When we develop a bridge, or when we build a bridge, if we are building a bridge first time, so we may not be taking many of the precautions. We may not be taking many of the precautions. Once we develop a bridge, so maybe because of high wind, maybe because of heavy rain, if any fault occurs, if any problem occurs to my to the bridge which we have developed, so then we'll understand that these precautions we have not taken care. So when we develop a when we reconstruct it, or when we develop a bridge in other places, then all these whatever the failures we face in the previous project, correct? Now students, we take care, we should not we should take care, we'll take care that the same mistake should not repeat in our future projects, correct? Why? Because in the previous project I have done, these are all the mistakes, or these are all the faults I have done. So because of these faults, my product or my bridge, whatever the bridge I have constructed, it is not helping to the people. So in the next project, I want to change, I want to improvise my work. So one more example here, a plane crash because of, maybe because of some technical issue, aircraft crashes. Then in the next future, in the future, when I manufacture a new aircraft, that time I'll take care what I'll see that because of what fault my plane has crashed. I have to do the detailed study, students, before I go to the I take up a next project. It may, see students, it may be a simple project or it may be a complex project. If I am developing a first time, whatever the failures I am getting here, so I have to do a detailed study of that. I have to find out what is the reason behind that. What is the reason behind, because of what reason I got a failure, failure in that in the project. If because of, once I find out the reason, so I have to rectify, I have to resolve the problem, error, and next time I should not repeat the same mistake. That's why here in the first point itself, it is there that engineers will study for the failure to understand how to improve, how to prevent a similar failure in the future. Here, experience with common software faults sometimes lead to improvement in design methods and programming languages. So experience, so if I have a less experience, then I may not be, if I have a less experience, then I may do some faults in the program. If you give a project to a well experienced people or well experienced engineer, then the failure or the fault rate may be reduced compared to the new engineers. If you give a same project to a fresher, if you take give a same project to a fresher or a experienced engineer, here in the fresher the rate of faults will be more compared to the rates, compared to the experienced engineer. The rate of faults or the rate of errors will be less in the experienced engineer. So the experience with common software faults sometimes lead to improvement in design methods and programming language. Sometimes if you give a project to a fresher, a commercial project or a complex project, if you give, then first what that they may not be knowing the new technologies which have come in the market. They may not be knowing, so whatever the existing, whatever they have studied, using that only, if they start developing, then maybe it takes more time uh, to to develop the project. Whereas the experienced engineer, the experienced engineer is already knowing what are the new technologies, new tools are available in the market. So based on that, they develop the project. Maybe the time taken to develop that project will be less compared to the fresher, compared to fresher, because the fresher is not having much experience, whereas the experienced engineer is having more experience, and he knows the whatever the new technologies tools are available in the market, so that he can develop a project in a lesser time and cost effective also. For example, the main purpose of automatic memory management in Java is not the spare the programmer to trouble the release unused memory, but to prevent the programmer from making the kind of memory management error. So here one example they have given. So in some programming languages we have automatic memory management. So we have a automatic memory management. Once we have a depth knowledge, because the see I told here the experienced engineer will be having a more knowledge compared to fresher. So here compared to C and C++, compared to C and C++, Java is having more advanced features. Java is having more advanced features. So the fresher may be thinking that he can use C and C++ to develop a project. But the experienced engineer, he has more knowledge on the program. He has more knowledge. So directly he can use a Java programming language, because we have a very good features or important features, very efficient features compared to C and C++. The basic concept of fault-based testing is to select a test case that would distinguish the program under test from alternative program that contains hypothetical faults. The basic concept of this fault-based testing is to select the test cases, to reach our hypothesis. If the test case is wrong, then even our hypothesis will also be having will get a faults. This is usually approached by modifying the program under a test to actually produce the hypothetical fault program. So this is usually approached by modifying the so when we modify the program based on the fault so that we can develop a good project. Next we have assumptions in fault based testing. The effectiveness of fault based testing depends on the quality of the fault model and some basic assumptions about the relation of the seeded fault. Okay, students, before I start with this fault assumptions, so when I give you to develop a project, what types of faults you may do? So we'll have some discussion on this. So before I go to the next topic, so we'll have some discussion. So what types of fault we may do? Rajeshwari, are you there? Rajeshwari, when I
Yes, ma'am.
ask you to develop a project, what type of faults you may do? It's what type of fault? So what type, you will develop a project without any faults?
Don't know, ma'am.
Huh? ಹೇಳಿ ಬೇಗ. What is fault according to you? Yes, Srinidhi? You understood the topics which I have explained here, Rajeshwari,
Yes, ma'am.
the introduction part. Here, here I gave the example, no? One example here, the car example. Here, the plane crash, the crashes of an airline crash. Sorry, the causes of an airline crash are likely extensively studied, and when raised to a structural failure, they frequently result in a directive to apply diagnostic tests to all aircraft considered potentially vulnerable to similar failure. This is one example, and this is a bridge example. So here, what happened in the bridge? So first, they have in 1940 they have constructed a bridge. So because of high wind, something went wrong in the bridge. So um, when they whatever that something went wrong, no, so what it is because of what error, what fault it has went wrong, so that detailed study we have to do. So same thing in the case of plane crash also. So because of the structure because of the structural design, maybe it has not done properly because of that, or maybe because of technical issue, the airline has got crashed. So first we need to find out what are the errors. So what are the errors? So based on the error, we will try to rectify, or we'll take care that next time that error should not occur. That error should not happen. So similarly, here I'm asking you before I begin with the fault-based testing. When I give you a project, what types of faults you will do? What types of mistakes you will do? ಏನು ಮಾಡೋದೇ ಇಲ್ವಾ ರಾಜೇಶ್ವರಿ? ಎಸ್ ಶ್ರೀನಿಧಿ, ಶ್ರೀನಿಧಿ ಫಾಸ್ಟ್. ಶ್ರೀನಿಧಿ,
Yes, ma'am.
if I assign you some project, so what type of faults you may do?
Ma'am, technical fault
Technical fault, okay, and
and some errors. human errors,
Human error. Very good.
and validations and
Validation. And okay.
test cases,
Test cases. Test case error. Okay.
means behaviors.
Okay. Okay. Good. Savita. Mega mega. Savita. Are you there, Savita? Idi Beka. Yes, students. What is fault? What type of faults? Savita, are you there, Savita? I'm not able to hear you, Savita. Are you telling anything? Okay. So, assumption in fault-based testing, a student's fault is nothing but a mistakes or the error when which we do when we start developing a program. It is a most commonly we do the errors. It may be a logical error, it may be structural error, it is a component error. So we cannot say that what type of error faults we do. So once we run our project, only then we'll come to know what error, where the mistake has happened, where something has went wrong. So only then we'll try to find out the fault. So the effectiveness of fault-based testing. So see, this fault-based testing is very much important, students. So we have to check for each product. We have to check where we have done a fault, where we have done the mistake, so that it will be helpful for us to rectify or and the error or the mistake what we have done next time will not we should not will not repeat it.
Excuse me, ma'am.
Yes,
Ma'am, screen share ಆಗಿಲ್ಲ.
sure. Thank you, Rashmi.
Ma'am.
So when we why this fault-based testing is important is when we develop any project or a product. So we'll try to find out what missed it. The fault may be um, any component error or any logical error or any technical error. So once we come to know what fault we have done, so that it will be helpful for us to rectify and will not repeat in the future or in the future projects or in the future applications. So the effectiveness of fault-based testing depends on the quality of the fault model. See here, the quality of the fault model is also very important. So the effectiveness of fault-based testing depends on the quality of the fault model and on some basic assumption about the relations of the seeded faults to faults that might actually be present. So we have to find out what fault we have done. So once we means we have to rectify what fault we have done. So once we rectify the fault in our program, so that it will be easy for us to will not repeat in the future project. So in practice, the seeded fault. Seeded fault. What is seeded? Seeded means the planted faults, or the fault means faults which we have done, faults which we have done, or faults which we have made. The seeded faults are small. The seeded faults are small syntactic changes, like replacing a variable references by another in an expression, or changing a comparison from less to less than or equal to. We may hypothesize that these are representative of a fault actually present in the program. Yes, students, when we come to know the faults, when we come to know what errors we have done, so we may change the variables in the program. If it is any variable error, so then we will try to replace the variables. We will try to replace the variables in an expression, and we may also change the values, the expression values, like see, you can see the symbol now, where I'll highlight. Wait, I'll highlight this. See here, you can see the expressions, the symbol. That is, the expression may be the comparison. The symbol is first I'm using less than. For our to rectify the fault, I may change the less than symbol to less than or equal to. See, why we are doing all these changes is to reach our hypothesis. To reach our hypothesis, we are doing this change. See, in the seeded fault is nothing but the faults which we have made are small. They may be small. They may be any syntactic faults. Syntactic faults is nothing but some syntax error, or sometimes we may be replacing one variable by the another variable. See, these are all. Here what we are doing is, once we are we done the fault, no, once we are doing a mistake in the program, so here we are checking the syntax. We are checking the syntax. Did I do any syntactic error? And here we are replacing the variable. Sometimes the value of the output is very large. It is in lakhs. But I have declared the variable as integer. Yes, students, you are understanding? I have declared the variable as integer, but the output is in lakhs. It is, the range of this integer is minus 32,172, minus 32,000 to plus 32,000, but my output is in lakhs. So this variable is whatever the variable which I have declared as an integer, so it is not able to hold that output. So it will display some garbage value. So here, in some situation, we may also have to change the variable also, variable in an expression. And here the expression which I have taken is less. So in some situation I may have to change it to less than or equal to. Like this, I have to do some of the changes in the program. Some program faults are indeed simple typographical error also, and sometimes while typing, if I have not done any logical error, so sometimes while typing also we may do some mistakes. So some typo errors also will be there. So we have to rectify the typo error also, the textual information. If any difference in the text also, we may not get a desired output. Sometimes through an error of logic will result in much more complex difference in the program text. And here because of the logical error, if the logic only changes, then we get a lot of difference in the output. Yes, students, here if we have done any minor mistake, if we have done any minor mistake, then also we don't get a desired output. If we do any logical error, also, we do not get a expected output. So these are all the places where we can find the faults. Yes, students, these are all the places where we can find the faults, that is in the syntax, in the variables, and in the expressions. And sometimes we'll do the typo error. So typo error we do when we type a message. Also sometimes we do a spelling mistake. Then again we'll send typing error or typo error. We'll send no. And next is a logical error. If we do any mistake in the logic, so logical error will occur. This may not invalidate fault-based testing with a simpler fault model, provided the test cases sufficient for detecting a simpler faults are efficient also for detecting a more complex fault. This is also known as a coupling effect. Sometimes only these are all not a proper way to find out the error. We have to write a test cases. We have to write a test cases to find out what error we have done, what mistake we have done. So that writing a test cases is known as a coupling effect. It is also known as a coupling effect. And next we have some of the terminologies of a fault-based testing. A student that I'll take it in the next class. So I'll repeat this slide once again. A student, here in fault-based testing, so we may do different types of faults. The different types of fault means the syntax error. The fault here mainly we'll understand fault is nothing but some error or some mistake in the program. What type of mistake we do? Yes, listen carefully, students. What type of mistakes we do? We may do a variable declaration mistake. Yes, here I told that my output is in lakhs, my answer is in lakhs, but here I have declared a variable, integer variable. Integer variable can hold only up to 32,000 because a range is less. So in this case, I have to go with the long int variable. So while declaring a variable, also I may do some mistake. In the syntax also I do some mistake. And when I write a expression, there also I may do some mistake. So once I run the program, only then I'll come to know what mistake I have done. Correct now? So what mistake I have done. And sometimes we may also do a mistake in the typing. The typographical error also we may do in the program. And some errors are the logical errors. Logical errors, for example, here is equal to 4 mod, sorry, here, what is the formula for leap year? Year mod 4 is equal to 0. So instead of this mod, if I make this star, here I am not doing any syntax error, but here the logic only wrong. Correct? No? Here I am writing a wrong logic. The logic is year mod 4. The logic is year mod 4, but here I am writing year into 4. So this is a logical error I am doing. And uh, so these types of faults we may do in the program. So here they are telling not only rectifying these fault in the fault detection. To rectifying these fault is not sufficient. We have to write the sufficient test cases. We have to provide a sufficient test cases to find the faults in the program. So that process of writing a test cases to find the complex fault, that process is known as coupling effect. That process is known as coupling effect. So next we have fault-based testing terminology. This I'll do it in the next class, students. This I'll do it in the next class. Yes, students, today's assessment, the link I'll share in the chat box. Assessment link I'm sharing in the chat box. I'll give you 5 minutes. In 5 minutes, you have to complete the assessment. Meanwhile, you answer your attendance, students. Answer your attendance. Asta? Asta is not there. Abhinav? Aishwarya?
Present, ma'am.
Ambrish?
Yes, ma'am.
Anu?
Present, ma'am.
Arbaz? Arbaz? Arjun?
Present, ma'am.
Ashok?
Present, ma'am.
Benita?
Present, ma'am.
Bhargavi?
Yes, ma'am.
Bhavisha?
Present, ma'am.
Chaitra?
Present, ma'am.
Dev?
Present, ma'am.
Diksha?
Present, ma'am.
Dikshita? Sorry. Deepika L?
Present, ma'am.
Deepika M?
Present, ma'am.
Murli? Murli? Absent. Gangubai?
Present, ma'am.
Gudiya?
Present, ma'am.
Harshid?
Present, ma'am.
Junjar? Junjar absent? Absent. Kavya?
Present, ma'am.
Kishore? Lata?
Yes, ma'am.
Manisha? Manisha absent. Manjunath?
Yes, ma'am.
Nayana?
Present, ma'am.
Nilanjan?
Yes, ma'am.
Nishant? Nishant, what happened to this boy? He's not attending. Pavitra?
Present, ma'am.
Maithili?
Present, ma'am.
Priyanka?
Present, ma'am.
Pawan?
Present, ma'am.
Akash?
Present, ma'am.
Rajeshwari?
Present, ma'am.
Rakesh? Rakesh? Ramya?
Present, ma'am.
Rashmi?
Present, ma'am.
Ravishankar?
Yes, ma'am.
Rizwan?
Present, ma'am.
Vishal?
Present, ma'am.
Savita? Savita? Savita is not there. I think she's sleeping. She's not responding for the attendance. Just she has connected. Sneha?
Ma'am, Shruti.
Yes, ma'am.
Oh, yes. Shruti?
Present, ma'am.
Sneha?
Yes, ma'am.
Spurti?
Present, ma'am.
Srinidhi?
Present, ma'am.
Srinivas?
Present, ma'am.
Sunil?
Present, ma'am.
ವೈಷ್ಣವಿ ಯಾಕೆ ಸುನಿಲ್ ತುಂಬಾ
Present,
ಖುಷಿಯಾಗಿದ್ಯಾ ನಗ್ತಾ ಇದ್ಯಾ ವಿನ್ನಿ ವಿನ್ನಿ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಆಲ್ಸೋ ಶಿ ವಾಸ್ ಆಬ್ಸೆಂಟ್
Savita present, ma'am.
So when I called your name that time, why you didn't respond? Arbaz,
Yes,
Asta, Abhinav, Murli absent. Junjar, I saw him, but he is not responded for the attendance. Manisha is not there. Nishant. Nayana is there? Nayana. Nayana? Neelanjan?
Yes, ma'am.
Nayana? Vinny is absent, no? Yes, students, finish your assessment.
Yes, ma'am.
Complete your assessment, students. Twenty-two responses ಬಂದಿದೆ. What about the remaining students? Complete your assessment, students. Complete fast. Students, any doubt? Any doubt? Today we have started with the new module. Any doubt in this, in the topics which I have covered? Okay, students, I'll stop here. See you in the next class.